Hi everyone. Today I have a question to start our discussion. You can see on the screen there are two images. First one is fire. Second one is iron. I have the first question for you is, this question is written on the top, identify the physical state of. So what is the physical state of fire? That's the first question. That probably you may take some time. And maybe the lower ones are familiar. What's the state of iron? You can see the iron pillars, iron poles. Probably all of you will say, oh yeah, that's in solid state. Then if I take nitrogen, that shows liquid nitrogen poured out and it is getting vaporized, and the state of that vapor, or it's in a gaseous state, we can say. Vaporized nitrogen is in its gaseous state. Moving on to the final image, it's lava, molten lava flowing out. So hopefully you understand that's a liquid state. I'm moving back. I have examples of solids, liquids, and gases. One solid, liquid, one gas. Now, my question is, what is the physical state of fire? Some of you may be knowing, it's called a plasma state. That's a fourth state of state. So today, we're going to talk about the various states of matter. That's what our topic today. This is the first topic also in IGCSE chemistry syllabus. First topic is the particulate nature of matter. So we talk about the first point, we talk about different states of matter. Before I introduce the topic in detail, this is just to familiarize you with the syllabus. Syllabus is divided into core content and its extended content, and you can see the details. Okay, then there is a definition for matter. Matter is anything which occupies space and has mass. So if a substance to be called anything, if we call it substance, it should be matter. So matter is anything which occupies space and should have mass. Examples, there are solids and liquids and gases. Examples are given in all three states. Do you have anything which is not matter? So when we say anything around you, anything which you can touch, see, feel, etc., they are all matter. Gas, you can see oxygen, nitrogen. What about air? Air is a mixture of different matter. We should say carbon dioxide is there, oxygen is there, nitrogen is there. So it's a mixture of all this. So anything which is not an example of matter, I would say vacuum. Vacuum is not an example. It's not a matter, basically. Or we can also say that these are examples of, different physical states of matter. Now, let us see the arrangement of particles in three various states of matter: solids, liquids, and gases. Arrangement of particles and some other properties. You might have seen it, you might have learned it. In lower classes, actually we learn, but it is a consolidated learning in grade 9 and 10 or in IGCSE. IGCSE is usually done in 2 years. If you're doing it in 2 years, this is the first topic. Usually we do it in grade 9. So the first point of discussion is about arrangement of particles. You can, in IGCSE, you need to explain it as regular arrangement of particles and they are closely packed. So there are like 2 points for you to write. If a question comes, describe the arrangement of particles in solid state. Particles are arranged in a regular way and they are very closely packed. What about in liquids? Next one, in liquid. Liquid, you see the particles are irregular, that's a difference, and still they are closely packed. Closely, it means it could be very close, it may be slightly far apart. So in liquids, the particles are slightly far compared to solid state, right? Otherwise, we can use again the wording closely packed in liquids as well. They accept it. When it comes to gaseous state, you can see the particles are far apart, and the arrangement we write irregular again or random, and the particles are far apart. Irregular and particles are arranged far apart. So there is only one regular arrangement, that's for solids. Now, the next one is movement of particles. You definitely need to know what type of movements are allowed in solids, and they only vibrate. So that's a key word, vibrate. And then when it comes to liquids, particles can slide past each other. That is a proper wording. They slide past each other, and they slide over, not only vibrating. Is vibration still existing? Yes, they're still vibrating, but more than vibration, they can slide past each other. Moving on to the next, that is gaseous state. The particles, they are just free random movement. Particles move freely, and that is a random movement of the particles. If we are done with that, then the space between the particles, the next one, we say the first one is no space for solids between them, hardly any space between them. Whereas in liquid, you see there is some space. You could say medium space, slightly more than solids. And when we check the gases, they have maximum space between the particles. That's very clear from the diagram. You can see that. Next is the forces of attraction between the particles. It's obviously, probably you remember it. This has maximum forces. Solids have maximum forces since they are closer to each other. They have maximum forces. Then you can see the medium force in liquids, and there is no force. We would say there is no forces of attraction holding the particles together in gaseous state. Now, after this, let us check a simulation on this. I would just open the simulation part. Just wait for me to open that. Let me share my screen. That is share. Yeah, this is the simulation. This simulation we can do that shows the interconversion of states of matter. This is the parameters. You can clearly see the right atoms and molecules. What atom is displayed here? It's right at the moment. We have selected neon. Yeah. Then there could be argon, oxygen. You can see the differences. Neon and argon, they are noble gases. So a molecule means it's a single atom. When it comes to water, the molecules are 3 atoms together. Yeah, so we start with the neon. Here I can heat. When I heat, let me start from the beginning. What state is this? It is solid state. The particles are just vibrating, and there is a regular pattern arrangement, and I'm giving heat. You can see the solids, what happened? They melted, they changed into liquid state. I continue to give heat, and some particles are leaving from the surface into the gaseous state. And if I continue to give heat, and almost all of them are getting converted into its gaseous state. See, the temperature is measured as 41 Kelvin, and I keep on adding more particles or more atoms of neon into it by pumping more into. You can see the pressure gauge on the left hand side, it is reading and the pressure is increasing, and also I give heat. pressure keep increasing, temperature is also increasing because I'm supplying heat. The solid converted into liquid, converted into gas. All of them are in gaseous state. Right. So pressure keep increasing. That's also a concept you have to learn in IGCSE. It keeps increasing, increasing, increasing. And let us see. Pressure is increasing again because we are heating and the molecules are moving faster. That's why pressure is increasing. They are colliding, they are hitting the walls of the container. The lid is gone off. Because of the huge pressure, we can do the return of lid. Molecules have already escaped. So if you want more molecules, you can pump in more molecules. You can cool down. You know, when I draw this control, when I use cooling control, when I use, I reduce the temperature. You can see the gases, gas molecules convert into a liquid and then they solidify into its solid. See, it's solid. Particles are just cool down and they don't even vibrate. It doesn't show that it is vibrating, but actually it is vibrating, right? Now it started vibrating. So it's back in the solid state. That is today's lesson. Just an introduction on